In this video, we are going to look at some problems in limits. Evaluate the limit below. Limit as x approaches 0 of x squared into bracket x squared plus 2 cube minus 8 divided by x squared. So this is equal to limit as x approaches 0. Now, want to write this 8 as 2 cubed, so it becomes x cubed plus 2 all cube minus 8 is the same as 2 cubed divided by x squared, bracket close. Now we want to use an identity, which is a cube minus b cube is the same as into bracket a minus b, then times another bracket a squared plus ab plus b squared. So that is how we want to write this, and therefore this is equal to limit as x approaches 0. Then the whole of this becomes a and then 2. So x squared plus 2 becomes a and then 2 becomes b. So this bracket becomes into brackets x squared plus 2. Now I want to differentiate this, then minus 2. So let's differentiate this one, then times a squared, which is x squared plus 2 squared, then plus ab, which is 2 times, because b is 2, then a is x squared plus 2 cubed. Sorry. So this way, then plus b squared, and plus b squared is 2, which is 2 squared, all divided by x squared, then bracket close. So this is equal to limit as x approaches 0 of. Now let's open this. If we open this bracket, you can see that plus 2 and minus 2 will go away. So it becomes x squared times all of this, which is x squared plus 2 squared, and plus 2 times x squared plus 2, and plus 2 squared is 4. All of this divided by x squared. So from here you can see that this x squared and this one will cancel out. So we'll be left with, so this is equal to limit as x approaches 0. And then here is x squared into bracket x squared plus 2 all squared, and plus 2 times x squared plus 2, and plus 4. So from here we can make the substitution. So this is equal to x squared, so x is 0, we put in 0, plus 2 squared plus 2 times 0 squared plus 2, and plus 4. And this is equal to 2 squared plus 2 times 2 plus 4. This is equal to 2 squared is 4, plus 2 times 2 is also 4, then plus 4. 4 plus 4 is 8, plus 4 is 12, so this is equal to 12. Evaluate the following limit. So let's start with a. The a is limit as x approaches 1 of x minus 1 divided by 2 minus root x plus 3. You see that if you insert 1 into this function, the denominator becomes 0, which makes the function undefined. So what we need to do is to rationalize. So this is equal to limit as x approaches 1, then x minus 1 divided by 2 minus root x plus 3, and times, so we are rationalizing, it becomes 2 plus root x plus 3 divided by 2 plus root x plus 3. So this becomes limit as x approaches 1. So this will become into brackets x minus 1, then times 2 plus root x plus 3 divided by, now this becomes difference of two squares, so it becomes 4 then minus into bracket x root x plus 3 times root x plus 3 becomes x plus 3. So this is equal to limit as x approaches 1 and then x minus 1 into bracket then times 2 plus root x plus 3. If you open this bracket, it becomes 4 minus x minus 3, and 4 minus 3 is 1, so here becomes 1 minus x. You can see that here is x minus 1 and here is 1 minus x, so we need to factorize minus 1 out so that we can write this place to as 1 minus x. So this is equal to limit as x approaches 1 of minus into bracket 1 minus x then times 2 plus root x plus 3 divided by 1 minus x. So at the end of the day, this one and this one will cancel out, so we'll be left with this is equal to limit as x approaches 1 of, what we are left with is minus into bracket 2 plus root x plus 3 bracket close. So at this point you can put in the limit, and this is equal to minus into bracket 2 plus root 1 plus 3. Now this is equal to 1 plus 3 is 4, root 4 is 2, 2 plus 2 is 4, so here is equal to minus 4. Now let's come to the b part. The b part is limit as x approaches minus 1 of x squared minus x minus 2 divided by x squared plus 3x plus 2. So you can see that all we can do here is that we can factorize both the numerator and then the denominator. So we look for two numbers that if you multiply you get minus 2, but if you add you get minus 1. So it is minus 2 and 1. So this limit, so let me write it here. We are solving limit as x approaches minus 1 of x squared minus x minus 2 divided by x squared plus 3x plus 2. So here is minus 2 and then 1. So this is equal to limit as x approaches minus 1 of, so the numerator is becomes x minus 2 and then x plus 1. And the denominator, two numbers that if you multiply you get 2, but if you add you get 3. So it is 2 and 1, and therefore the denominator becomes x plus 2 and then x plus 1. And you see that this x plus 1 and x plus 1 can cancel out. So at the end of the day, the limit is left limit as x approaches minus 1 of x minus 2 divided by x plus 2. So we can go ahead and insert the limit. If you insert the limit, it becomes minus 1 minus 2 divided by minus 1 plus 2. Minus 1 minus 2 is minus 3. Minus 1 plus 2 is 1. And this is equal to minus 3. Evaluate the following limit. A. Limit as x approaches 0 of root x plus 3 minus root 3 divided by x. So what we need to do is to rationalize in this case. So this is equal to limit as x approaches 0 of root x plus 3 minus root 3 divided by x then times. So if you rationalize, you just find the conjugate of the numerator and multiply both the numerator and denominator by the conjugate. This becomes x plus 3 and plus root 3 divided by root x plus 3 plus root 3. And this is equal to limit as x approaches 0. So you see that here is difference of two squares, so it becomes x plus 3 then minus 3 divided by x times into bracket root x plus 3 and plus root 3 bracket close. So this is equal to limit as x approaches 0 of, now x plus 3 minus 3 becomes x divided by x times root x plus 3 plus root 3. You can see that this x and this x can cancel out. So it becomes limit as x approaches 0 of 1 divided by root x plus 3 plus root 3. So at this point, you can insert in the limit. So this is equal to, let me continue from here, 1 divided by root, so this is equal to, let me write it here, 1 divided by root, and x is 0, 0 plus 3 plus root 3. And this is equal to 1 over root 3 plus root 3, which is equal to 1 over 2 root 3. But we can rationalize, so times root 3 divided by root 3. So this becomes root 3 over 6. Let's come to this part, which is limit as x approaches infinity of 3x squared plus 4x plus 5 divided by x squared minus 5x plus 7. You see that we cannot factorize this function easily, and you can see that the highest power of the numerator is equal to the highest power of the denominator. So in the case where the highest power of the numerator is greater than the highest power of the denominator or equal to, and what we can do is that this is equal to limit of as x approaches infinity, and you take the highest power of the numerator, which is 3x squared, and divided by the highest power of the denominator, which is x squared. So this is equal to limit as x approaches infinity, and this can cancel out of 3. This is equal to 3. Evaluate the following limit. A, limit as x approaches 2 of x squared minus 4 divided by x squared plus x minus 6. So this is equal to limit as x approaches 2, and x squared minus 4 is the same as x squared minus 2 squared divided by, now we can factorize this. You see that we look for two numbers, and when you multiply you get minus 6, but when you add you get 1. So those numbers are 3 and then minus 2. So here becomes x plus 3, and then x minus 2. And this is equal to limit as x approaches 2. Now this numerator is difference of 2 squares, so it becomes x minus 2 in one bracket times x plus 2 in another bracket divided by x minus 2, then x plus 3. So at the end of the day, this 2, x minus 2 and x minus 2 cancel out. So it becomes limit as x approaches 2 of x plus 2 divided by x plus 3. Now at this point we can insert the limit. So this is equal to 2 plus 2 divided by 2 plus 3. And this is equal to 2 plus 2 is 4, and 2 plus 3 is 5. So divided by 5. And let's come to the side. So this is equal to limit as x approaches infinity of minus 5x plus 2 divided by 5x squared plus 2x plus 9. Now you see that here, if you factorize in it, in this case factorization is not going to work, rationalization is not also going to work. So the rule says that limit as x approaches infinity, what we'll do is that we'll take the highest power of the numerator, which is minus 5x, and divide it by the highest power of the denominator, and that is 5x squared. This is equal to limit as x approaches infinity. Now this one can cancel one of the squares, so it becomes minus 1 divided by x. So this becomes minus 1 divided by infinity, and this is equal to 0.